Want some bite size? Yum!
Hey guys, it's Mr. Dave with the National Museum of Nuclear Science and History, and we're back with another bite-sized video. Now, all of our bite-sized demonstrations that we do have got a rating from 1 to 5, so you know how difficult those things are to do at home, how tricky, how safe, all those kind of things. Now, this one here, if we had one as a grab the doorknob and shock your hand, and we had 5 as a lightning strike, this would probably be about a 1.5. So this is an easy one. There are a couple things I want to show you about it, but we are messing with electricity. So you want to make sure that even though this is a safe level of electricity, that you've got an adult around to help you out with this, because they'll probably enjoy doing this one with you. Now, the materials for this are pretty simple, pretty easy. Probably stuff you have around the home. Alright, so you want to make a plasma cutter. The materials we need are really pretty simple. What we have is batteries. These are 9-volt batteries. I have 4 of them, okay? I have alligator clips, right? It's just 2 clips on the wire. These are those little clippy things. And we have this. Now, we don't actually need the whole pencil. What we need is the inside. What we need is that graphite, okay? Now, we call it the lead of a pencil, but it's actually graphite. They've been using graphite for a while now. It's a little bit safer. So what we're going to start with doing is taking our little piece of graphite, and we are going to clip it into one of our alligator clips, okay? That's going to give us our little stinger for our plasma cutter. Now, actual big commercial plasma cutters will use an arc of electricity or an arc of plasma, and it will superheat, or it will heat gas that they're pressurizing through. Well, that pressurized gas, now all of that gas gets heated to the level of plasma, and that's what they use to cut big metal. Now, we're not going to be applying argon and oxygen and all those kind of things. We're just using the atmosphere, the air around us, so it's not pressurized like those big ones, but we just need to cut a little something. We're going to cut aluminum foil. Okay, now this aluminum foil is a little bit thinner than the big things they cut with those big commercial plasma cutters, so we don't need the voltage, we don't need that pressurized gas. We're going to use our batteries, okay? Now what we're going to do first with these batteries is we are going to put them in cereal. Now, don't get the wrong idea, don't put batteries in your cereal, okay? Put batteries in your cereal, a little bit of milk, a little bit of sugar, whatever. That's not the kind of energy you need, okay? Don't put batteries in cereal. But we're going to put batteries in cereal, okay? In this case, it means in a series or in a line. So we're going to hook the negative to the positive of these batteries, and we're going to continue doing that, negative to positive. And what we're doing here is we're putting these batteries in serial, and when you do, you up the voltage, okay? These batteries right here are 9 volts, but we have them all in serial, so you would add those volts together, and so you can probably figure out how many that volts that is. You can maybe put that in the comments, let us know how many volts this would be. This is a fun one for the younger guys, just figuring out the addition there, or multiplication, okay? Now, for you older guys, you can figure out some stuff like, okay, well, this is our voltage. What is the amperage on one of these batteries? Does or does this not change? So there's a lot of ways you can take this if you're schooling at home and make this into a math project. You can make this into a physics project. You can make this into even an art project because we're going to use our plasma cutter to cut little shapes and lines in that aluminum foil. So I'm going to hook my red side, okay, with my little lead. I'm going to hook it up to the positive on this battery, okay? And then my other one, it doesn't matter whatever color you have at home, this one happens to be yellow, I'm going to hook that up to my negative on this battery. So as you can see, we have a circuit, okay? Now that circuit's not closed yet. We're going to do that with our aluminum foil. But I'm going to set this on the table here, okay? And I'm going to cut a little bit, and then we're going to turn the lights out so you can see a little bit more of that arc. Now our negative side, we are hooking to our material that we're cutting. Our positive side here has got our stinger on it, and we are going to just slowly move that along this aluminum foil. And when you do, you will see that that Cuts right through that aluminum foil. Now this is electricity. This is something that you're going to want to be careful with, but it's really not a dangerous amount of electricity. If I were to touch both sides, I'm not going to get electrocuted. But anytime you're dealing with something like this, there is the possibility of heat. So you need to make sure you're careful, make sure you've got an adult with you. But we can see here that little plasma cutter will cut right through that foil. Okay? And if we see it in the dark, you can see a little bit more of that arc and those sparks there. So anytime you're dealing with electricity, make sure you've got some parents around, make sure you've got somebody that understands the concepts and things like that. But really, like I said, this one, even though we see that arc there, it's a safe amount of electricity. Just make sure you're always careful, okay? So this one here, as you saw, we cut our little shapes. Now you can cut little hearts, you can cut whatever if you wanted to turn this into an art project. You say, hey, Mr. Dave, it'd be easier to just use scissors. It probably would be easier to use scissors. But using plasma, way cooler, okay? So hopefully you guys get a chance to build one of these and maybe experiment with different thicknesses of aluminum foil, maybe if you fold it over, things like that. Changes in your amount of graphite on your stinger there. And this can be a fun project, this can be a safe project, but make sure you have parents around because anytime you've got electricity, you want to make sure you've got some parents around. Thank you guys for watching. I'm Mr. Dave from the National Museum of Nuclear Science and History. Make sure you guys like and subscribe.